Hello everyone, I am Ananya Kumari of MTech IT 5th semester, and in this video I will be solving the section B of first internal question paper of data science. So let's start with the first question, which is briefly outline how to compute dissimilarity between complaint profiles for nominal attributes, for asymmetric binary attributes, and for numeric attributes, and the last is term frequency vector. So in nominal attributes we use matching, and if it is 0 then it is equal, and 1 if it is different, or a cost matrix. We also calculate dissimilarity by the total number of attributes that do not matched divided by the total number of nominal attributes, and if it is 0 then the things are the same, and otherwise 1. So for asymmetric binary attributes, we use asymmetric binary measure because 1, if there is 1 then it indicates presence, and if it is 0 it indicates absence. Is not common or not necessarily indicative. We also use Jaccard distance, and we calculate for presence only features, and we calculate it by subtracting the magnitude of intersection of both attributes divided by the union of both attributes and subtracting it from 1. This is how we calculate the Jaccard distance, where A and B are the set of present attributes. Here you can see in the PPT the formula is written. For single binary attribute, we should treat presence as 1 and absence as 0, and prefer measure that emphasize co-presence. For numerical attributes, we use Euclidean distance, Manhattan or normalized distances. So these are used for calculating the difference between 2 points in space, and we should scale or normalize numeric features using z-score, min minus, or min max, or robust scaling before combining. For term frequency vector, that are keyword phrases from documents, from FIR narratives, we use cosine similarities between TF or TF-IDF vectors to measure the similarity of narrative text. This is calculated by calculating the dot product of two vectors, and the more it is in magnitude, it indicates the similarity between the two. We can also use Jensen-Shannon or distance between embedding vectors. So we can convert each attribute to a per attribute dissimilarity in the range of 0 and 1, combined with a weighted sum by using the equation I've mentioned down there, and normalize weight. So this was all for the first question. Moving to the next one, we have tuple or entry of vectors extracted from FIR narratives, and 5 complaint exhibit evidence scores as given there in the table. And we need to compute the following distance measure among the complaints. So answer to this question is, here are the tuples given. For T1, there is a tuple with 22, 1, 42 and 10. Here you can see all the tuples are given 22. Yes. So here in this question we have been given 2 tuples, and we are supposed to calculate Euclidean distance, Manhattan distance, Minkowski distance with h is equal to 3, and supremum distance. So in step 1 we need to compute the feature wise difference of the tuple, which is, here you can see 2, 2, 6 and 2. So for Euclidean distance, we just calculate it this way, that is written down there. we calculate the square of each item and then we sum it up and then we calculate the square root of it. This is how we get Euclidean distance. For Manhattan, we just sum up all the points. For Minkowski, where h is equal to 3, we calculate the cube of each item of tuple, then sum it up and calculate the cube root of it. And the answer is calculated to be 6.2145 approximately. For supremum or Chebyshev distance, we calculate the maximum value among the tuples. We identify the maximum value among the tuples after computing the feature-wise difference. So here we can see that the supremum distance, select the largest among individual coordinate difference. Manhattan distance adds all absolute differences. Euclidean distance takes the root of squared differences, and Minkowski lies between Euclidean and supremum distance in magnitude. So this is how question 2 is solved. Moving towards the third one. Here we have been given the problem statement in which there is the mean evidence input score is often a robust indicator for triage, routing to fast track scrutiny versus detailed legal vetting. For massive complaint datasets, propose median approximation methods, analyze time space complexity, and suggest heuristic to balance accuracy versus efficiency. So, solution to this: first of all, why median? So, median is robust to outliers and skewed evidence impact scores, good for triage threshold decisions. Approximate or streaming method for median can be p-square algorithm, which is an online quantile estimator. It maintains a small set of marks and updates them streaming. And with the complexity of O1, which is a constant memory per marker, it is good for single quantile. Then there comes Greenwald-Kanner summary. It provides the error approximate quantiles with time complexity O1 by E log En, where it guarantees the good worst case. Talking about the t-digest, it is very accurate for extreme quantiles and it is widely used for real world data that is fast, that comes in huge volume with huge velocity. It is used for many quantiles. Then there comes KLL, Kiernan-Lang liability. Here, it is the state-of-art streaming quantile sketch with good space accuracy trade-offs. Reservoir sampling sort this sample subset uniformly, then compute the exact median on the sample. It is therefore simple, but accuracy depends on the sample size. It doesn't perform very good if the sample size increases. Batched or parallel, compute local quantiles per shard, then merge summaries. So how do we decide which one to choose? So we should use t-digest or KLL for production large data. If we have a larger data set, then we need to use these, and it will be more fast mergeable and it will give good accuracy. We should use p-square for very lightweight streaming if only median is required, and provide a small flag and track uncertainty of the return median. Question 4, we are given a table of tuples where a vector for 5 FIR complaint narratives representing TF IDF scores of extracted keyword. Calculate the Pearson correlation similarity between each pair of complaints. Construct the correlation similarity matrix for all 5 FIR complaints. Identify which 2 complaints are most similar based on the correlation values. So first of all, we need to calculate the Pearson correlation similarity between each pair of complaints. So in order to calculate that, we are using this formula. Here it is written. That is, first of all, we will have to calculate the sum of each item, the sum of difference of each item and mean divided to, and then multiply it with the, okay, so in this formula, x actually represent the value of one complaint and values in tuples, and y represent the values in tuples of another complaint. So here we calculate the mean of all these values in a tuple. The tuple set of we use the values of two tuples between which we need to calculate the correlation or similarity. So here the formula is, first of all, we need to calculate the difference of each data item in a tuple and its mean, and then multiply it with the difference of the value of another tuple and its mean, and then divide it with the square root of the sum of each sum of the difference of each data item and its mean whole square, multiplying it with the sum of each data item in another tuple and its mean and its whole square. So this is the formula, and here we calculate the similarity values using that formula given here. And then you can see that while calculating the similarity value in F1 and F1, we get 1. That is, F1 and F1 is similar. If it is 1, then it is 2 similar, or you can say identical. Here you can also see we are having 1 in diagonal, because here F2 is obviously similar to F2, F3 is similar to F3, F4 is most similar to itself, F5 is most similar to itself, and here F1 is a little bit similar to F2, 0.902. It indicates a value near to 1, that is similar but not identical. And here you can see F1, the similarity between F1 and F4 is 0.821, that is, it is a little bit less similar as compared to F2. So this table tells us which document is most similar or dissimilar to which one. And the highest Pearson similarity value that we got here between non-identical complaints or FIR is 0.956, which is between F1 and F3. Here you can see F1 and F3 we have 0.956. Therefore, F1 and F3 are the most similar complaint narratives based on TF and IDF keyword patterns. So here, by this, I would like to conclude my presentation. Thank you all for watching my video with so much patience. Thank you so much.